Good morning, student. Today we'll be discussing on our calorimetry part 2, and in today's heat capacity, specific heat capacity between we'll be discussing on difference between heat capacity and specific heat capacity. So we'll be discussing. After that we'll be discussing our principle of mixture. The principle of mixture we'll be discussing. And thirdly we'll be talking about the setup of calorimeter, and finally we'll be doing some of the numericals. So first we'll be looking at heat capacity. Let me change this one. First we'll be looking at heat capacity. So now suppose I am taking any mass of the body. So let the mass of the body be m. Okay, now I want to rise the temperature by giving heat. I'm giving heat in it. I'm giving this one in heat. Now I want to rise the temperature of this body by 1 degree C. 1 degree C. Therefore, and this amount of heat energy, that is required to rise the temperature of a body by 1 degree C. So here we are not talking about mass. Does not have any fixed mass, and this is known as an heat capacity. So here what we will write. So it is the amount of heat energy required to rise the temperature of a body by 1 degree C. So we know that now we can define as the amount of heat energy required to rise the temperature of the body by 1 degree C. So from here already, by looking at this picture itself, we come to know the definition of heat capacity. Things is the unit will be SI unit is equal to SI unit of this one is joule per Kelvin. So the unit of this one is joule per Kelvin, and it will depend on what? It will depend on the mass. So it will depend on mass of the body of the. Now second we'll be talking about the specific heat capacity, and the specific heat, in a specific heat capacity we are taking a body, and the mass of this body should be 1 gram, and whatever the heat energy is required to rise the temperature by 1 degree C or 1 Kelvin, or 1 Kelvin is called an specific heat capacity. Okay, so it is, so the unit of SI unit of specific heat capacity is joule, kg inverse, and Kelvin inverse. So this is the SI unit of specific heat capacity, and it will depend on the nature of the substance. Now we will learn some mathematical expression discussing about some mathematical relationship of some physical quantities. Number one, we'll be talking about heat energy. So heat energy can be assigned as Q, and it is equal to, change in temperature. Now when I said this change in temperature, remember that this is an initial and final minus, so there must be a change in temperature. So change in temperature into mass of the body into C. So into C. So these are all into. TMC we can write. So change in temperature into mass into C. C is what? Specific heat capacity. So C is equal to the specific heat capacity. This is equal to the TMC. Q. So what is heat? Heat is the product of change in temperature mass into a specific heat capacity. So this is a specific heat capacity, and this is mass, and this is change in temperature. Change in temperature. Now I want to go for here change in temperature. Change in temperature is now there can be change in temperature will be in of two ways. Number one is it can be because of the rise in temperature. Rise in temperature. If there is a rise in temperature, then final temperature minus initial temperature. Okay, and if there is an means falling down of temperature or loss of energy loss of temperature will be equal to initial minus final temperature. So just remember this one. Now we'll be talking about the specific heat capacity, mathematical expression for specific heat capacity. So we'll be doing specific heat capacity ka we'll be looking the formula of this specific heat capacity. So we already know that Q is equal to change in temperature into mass into specific heat capacity Now what we can do, we can make this one, this specific heat capacity is equal to what we can write, we can bring this one as here. So Q divided by change in temperature into mass is equal to specific heat capacity. So this is specific heat capacity. From the previous itself we can come out from here and find out the specific heat capacity. Now again another is now let's look for the heat capacity. Now for heat capacity I am writing a big this one, heat capacity. So it is nothing but C. So this is mass, specific heat capacity. This is actually a specific heat capacity. So from here itself we can also find out that C is equal to this C is equal to capacity. From here also we can find the specific heat capacity as delta C into M divided by M is equal to is specific heat capacity is AC. So here also we can understand that the relation between this one. Okay, now using this one we are going to solve some of the numericals. Now student will be talking on the principle of mixture. Now suppose here is a suppose here is two things. Now I am mixing for example I am mixing here, I am mixing two things. One is the green one. Now one is the green one, another one is what I am writing. I am taking the yellow one. I am taking the yellow one. So this is another one. This is the yellow color. Now what happened? This if this yellow wala is greater, having more heat energy as comparing to the green, as comparing to the that of the green one. Now what will happen? Heat always will flow from the yellow to green. It will always from the heat to green, because this is more heat and this is less. Now they will continue to flow until unless they become equilibrium. Till they will flow they will flow till they become equilibrium. Okay, so whatever the heat, so what is the heat energy? So this is also Q, and here also it will be Q. So whatever the heat energy is lost is will be equal to the heat energy that is absorbed. Okay, so the principle will say that the principle of it is whatever the heat energy lost is equal to heat energy absorbed. Principle of mixture, and it is based on whom? It is based on the conservation of energy. It is based on the conservation of energy. So here we have understand what is conservation of energy. Conservation of energy is state that energy can neither be created nor be destroyed, but can be transformed from one form to another form. So this one is nothing but you have to remember little bit, just remembering the conservation of energy. Now we will be discussing on some of the numericals that can come from here. So here we have seen a one question, that is the calculate the heat capacity of a copper vessels of mass 150 gram if the specific heat capacity of copper is this much. So we need to find out the heat capacity. So actually to find the heat capacity, we have to know the relation that C is equal to M into C. So this is the heat capacity. This is the formula of the heat capacity. This is heat capacity. This is heat capacity, and this is the mass, and this is what? And this is the specific heat capacity. We already know. So what will be the heat capacity? Heat capacity is nothing but given mass is equal to 150 gram, which is equal to, let's convert it this one into kg. So 150 divided by 1000 kg. Okay, and after that we can specific heat capacity is equal to how much? Specific heat capacity is equal to 410 joule per kg. Now we want to find out that the heat capacity. Now C is equal to, now how can we do this heat capacity? We'll use this formula. Mass is equal to heat capacity is equal to 150 divided by 1000 into 410. So what we do, we cut here, and after getting, if we multiply this one, then we'll get 615. We'll get 615 divided by 10, and which is equal to 61.5 okay joule per Kelvin. So this is the answer. Again another question: how much heat energy is required to increase the temperature of the vessels when each part is 25 to 35? So solution is equal to, so we will do the solution. So let me take the another color. So then this time let me take pink. So the change in temperature, initial temperature is equal to say I am taking T1 is equal to 25 degrees C. Final temperature T2 is equal to is 35. Now change in temperature is equal to how much? Is equal to 35 minus 25 degree C, which is equal to 10, which is equal to 10 degree C. We get now the heat energy. To find the heat energy Q is equal to, so this is a heat energy. We know that from the formula. Heat energy is equal to change in temperature mass into specific heat capacity, equal to specific heat capacity. Now we come to know from the previous one that heat capacity is equal to Q is equal to change in temperature is equal to 10, mass is equal to, so mass from the previous topic, previous question is 150 gram, so it's 150 divided by 1000 into how much here, C specific heat capacity is 410. So here we come to know, so we can do this one, and this one is gone, this one is gone, so we get 615 joule we get here. So to rise this one temperature we get 615 joule. So this is the answer again. Okay, again some more questions let's do. So one more question here is 130 1300 joule of heat energy is supplied to raise the temperature of 0.5 kg of lead from 20 to 40. Calculate the specific heat capacity. So in this question we need to calculate the specific heat capacity. So to do that, what we have to do is so heat energy is equal to given, we'll write given. So let me change the color. So given is equal to, heat is equal to Q. Heat Q is equal to how much? 1300, and temperature, change in temperature. So initial temperature T1 is equal to 20 degrees C. Final temperature T2 is equal to almost 40 degrees C. Now change in temperature, so change in temperature, so the delta means change in temperature, always remember, means change, so is equal to 40 degrees C minus 20 degrees C is equal to 20 degrees C. So we come to get here this much. Now second, now we will have to find out how much we calculate the specific heat capacity. So to find the specific heat capacity, we came to know, we using the formula Q is equal to change in temperature mass into C. So this is the specific heat capacity. This C is a specific heat capacity. Now this Q is how much? Q is they have given you 1300 joule, and which is equal to change in temperature is 20. Change in temperature is 20 degrees C. And then mass is equal to 0.5 kg, so it will be 5 by 10 kg. Okay, and C we don't know, we don't get here, so we just cut this one. So this one it can be cut with 2 6 is 12, 2 5 is 10, 0, and this one again can be cut with here 5 1 is 5, 5 1 is 5, and 5 3 is 15, 0. So it is C is equal to this is joule, 130 joule, okay, Kelvin inverse, okay, and this is also kg also is kg inverse and Kelvin, also degree C inverse. So this will be the answer for the specific heat capacity. So the specific heat capacity is 130 joule per kg per degree inverse. In case of this C, you can also write 130 joule, okay, kg inverse, and you can write Kelvin also, because same change in temperature will be same. You can write Kelvin or degree C also, anything you want you can write, any of these you can write degree C also, or in Kelvin also you can write. So here it is given that the amount of heat energy, the amount an electric heater of the power 600 watt. So it is 600 watt rise the temperature of 4 kg of liquid from 10 degrees C to 15 degrees C in time is 10 seconds. Calculate the heat capacity of 4 kg of liquid. We have to calculate first the heat capacity of the liquid and the specific heat capacity of the liquid. So here we have to calculate two things. Number one is heat capacity and another is specific heat capacity. Okay, to solve this one, so we know that power is equal to power of heater. So we will write just P is equal to how much? 600 watt, and now time is equal to time is equal to heated for, so time will write T is equal to, it's 100 second. So heat energy Q is equal to so it is the heat energy that is produced. Heat energy that is produced is equal to P into T. So it is the heat energy which is equal to, we can write 600 into 100 second is equal to 60000 joule of heat energy is produced. Now we are to find the heat capacity. So first we know that first we will find the specific heat capacity, then we will find again the heat capacity. We know that Q is equal to, okay, change in temperature into M into C, small c. So we come to know that Q is how much? Q is 60,000 is equal to time change in temperature. So again here change in temperature is equal to, here we come to know that it is 5. So 15 minus 10 degree C is equal to 5 degree C. So this 5 you have to look from the question. So change in temperature is equal to 5 degree C into mass is equal to, mass is 4 kg and C we will need to find. So we'll have to find first 5 1s are 5, so 5 1s are 5, 5 2s are 10, and this one 5 2s are 10, 0 0 0, and 4 1s are 4, 4 3s are 12, 0 0 0. So specific heat capacity is equal to, C is equal to, specific heat capacity is equal to 3000 joule per kg per degree C or degree inverse. So this much we can write. Here you in case of degree C you can write Kelvin also, no problem, or Kelvin you can write anything. So this is the answer. C is equal to 3000 joule per kg. Now we also need to find out what is that is heat capacity. So we know that heat capacity C is equal to C into M. So this is the specific heat capacity, this is the specific heat capacity. So when C is equal to how much? Specific heat capacity 3000 into mass is how much? Mass is 4, which 4. So we come to know that C is equal to 12,000 joule per Kelvin. Can write like this. So this is over. So thank you. If you have problem, you please contact me and I will send some more questions to you. Okay, thank you.